Assalamualaikum and good afternoon to Dr. Liana. So we are from Group 8. We are doing a project about online analytical processing using OLAP. Introduction, OLAP is a technology used to organize large business databases and support business intelligence. OLAP databases are usually divided into one or more cubes, with each cube designed to align with the way the data will be analyzed. For this project, we are using Google Cloud BigQuery, a cloud-based data warehouse designed for SQL-based analytics, which supports OLAP-style querying. The business domain we are interested in is about exploring in supply chain management. Okay, for our project, there are three objectives that we are planned to complete, which is the first one to design and implement a multidimensional schema, which is using OLAP Cube based on the chosen business domain using a suitable tool. And the second one, to perform OLAP operation such as roll up, drill down, slice and dice, and pivot. To reflect some key findings and challenges faced during implementation.
Alright, so now we'll take a look at the star scheme. So the diagram on the left represents a star scheme created to visualize the data connection for our project. And the fact table from our data set is the fact orders. So the foreign keys in fact orders are user ID and order ID, as you can see. And this foreign key connect order to user through the dimension user table, which the primary key in the dimension user table is user ID, and it also connect orders to product through the dimension order items table, where the primary key in that table is order items ID. The dimension user table is also connected to the dimension event table, which tracks user logs, and the primary key in this table is event ID. Next. Alright, so let's take a closer look at our fact table order. The fact table order contains quantitative data such as order ID, user ID, created at, return at, shipped at, delivered at, and number of item. And its qualitative data is the status. And for the dimension table user, our quantitative data is user ID. Meanwhile, the rest is qualitative data. For the dimension table event, our quantitative data is event ID, user ID, and sequence number. Meanwhile, the qualitative data is session ID, created at, IP address, city, state, postal code, browser, traffic source, URL, event type, and is missing user ID to track if user ID is missing. Last but not least, the dimension table for order items. The quantitative data is order items order ID, and sale price. Meanwhile, the qualitative data is status.
Alright, so we proceed with the OLAP queue design. So as you can see, X we assign as user, and Y we assign as order, and then for Z we assign as time. So we are going to do a measurement about the total sale by aggregating sales value across the all dimension. Alright, for next. Alright, so the dataset are obtained from the Kaggle, and then all the dataset was stored in by project assignment bucket in Google Cloud Storage in Google Cloud Platform. So the dataset was created in the BigQuery interface named sales data, and then 4 tables were created in sales data, and then we perform 4 queries, which is drill down, pivot, roll up, slice, and dice.
So moving on with the OLAP operation that we have done, which is roll up, drill down, slice and dice, and pivot to explore and analyze our data, as well as uncovering meaningful insight from multiple perspectives of our queue. So for roll up, this query calculates the total sales by country, which is a summarization of sales at a higher level of aggregation between different countries. As you can see, the top 10 countries is shown, and China is on number 1. Next slide will be a drill down, which shows the query that calculates the total sales by city within China, which means we will have a more detailed insight on the top one country, which in this case China, and we see that top three city is Shanghai, Beijing, and Shenzhen, with total sales of 26,000, 24,000, and 14,000 each. So next slide is slice and dice. We slice and dice the info that we have, which is Shanghai, Beijing, and Shenzhen. We see that the orders with status ship, and we put them together of all of the orders that have been created in 2024. So this slice and dice mean we slice them into what we have found before in the drill down operation and dice them into each of the year, which is in this case is the whole year of 2024. Next slide.
Okay, next, last is the pivot. The query generates a pivot table showing total sale for each product in Shanghai, Beijing, and Shenzhen, China for 2024. It aggregates the sale by city and product using array to display the product sale for each city ordered by product ID. And next. So for conclusion, the key findings, the first one is roll up, where it aggregates data for summarize, and then drill down, which breaks down the summarize to explore the details. Next is slice and dice to filter data for specific subsets. And the last one is pivot to reorganize the data by changing hierarchy or swapping rows or columns. Next slide. And then challenges and solution. The first one is OLAP tools expertise, where the data warehouse and tool exploration is needed, such as BigQuery and Apex Oracle. And next challenges is data exploration, where to understand the supply chain data for OLAP Cube development. And the last challenge that we face is workload distribution. So the solution is ensuring fair task distribution among team members for timely completion. So that's all from us. Thank you.